Hello grade 6, how are you today? I hope you are fine. We are going to study adding and subtracting integers. First, adding integers. We have adding two positive integers. For example, if we need to add two numbers, 2 plus 3. 2 is first number and 3 second number. First, we need to represent the set of integers on the line numbers. If we have here 0, and to the right we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. And we have to the left we have -1 and so on. So if we need to add 2 plus 3, we start from 0. So we start from 0 and move to the right the absolute value of 2. The absolute value of 2 equals 2. So we need to move to the right 2 units and stop here. So we moved to the right 2 units and we have number 2. Then we start now from 2. We start now from 2 and move to the right the absolute value of 3. The absolute value of 3 equals 3. So we need to move to the right 3 units. 1, 2, 3. And stop here. Finally, we have 5. So 2 plus 3 equals 5. And now what happened? We start from 0 and move to the right absolute value of 2. Why we move to the right? Because the sign of the first number was positive. And why we move from 2 to the right? Because the sign of the second number positive. So we move to the right. So first we start from 0 and move to the right. Move to the right the absolute value of 2. So now we have 2. And then we start from 2 and move to the right the absolute value of 3. Finally we have the answer. The answer is 5. So 2 plus 3 equals 5. So we deduce that adding two positive integers is the same adding in natural numbers. And now we have adding two negative integers. For example, if we need to add -2 plus -3. -2 plus -3. So -2 is first number and -3 is second number. And now we represent the set of integers on the line numbers. We have here 0 and to the right we have 1, 2, 3 and so on. We have to the left -1, -2, -3, -4, -5, -6, -7, -8 and so on. So if we need to add -2 plus -3, so we start from 0. Now the sign of the first number negative. The sign of the first number negative. So we need to move to left the absolute value of -2. The absolute value of -2 equals 2. So we need to move to the left 2 units. We have 1 and 2. So we will stop here. And we have -2. After that, we move to the left because the sign of the second number negative. So we move to the left. So from 2 moving to the left, the absolute value of -3. The absolute value of -3 equals 3. So we need to move to the right 3 units. 1, 2, 3 and stop here. Finally, we have negative 5. So, negative 2 plus negative 3 equals negative 5. So now we deduce that adding two negative integers equals negative integer. Now, adding two integers, one of them positive and the other is negative. For example, adding negative 3 plus 4. Negative 3 plus 4 using the line numbers. So we have 0, and to the right we have 1, 2, 3, 4, 5, 6, 7, and to the left we have negative 1, negative 2, negative 3, negative 4, and negative 5, and so on. So if we need to add negative 3 plus 4, we have negative 3 first number and 4 second number. The sign of the first number, negative 3, is negative. The sign of the first number, negative 3, is negative. So we start from 0 and move to the left. Move to the left. The absolute value of negative 3. The absolute value of negative 3 equals 3. So we need to move to the left 3 units. 1, 2, 3. And stop here. So now we have negative 3. Then we move from negative 3, the absolute value of 4, to the right, because the sign of the second number is positive. So we need to move to the right, the absolute value of 4. So after we have negative 3, we move to the right 4 units. 1, 2, 3, and 4. So now we have 1. So the answer is 1. So negative 3 plus 4 equals 1. So now we deduce that adding two integers, one of them positive and the other is negative, equals negative integer or positive integer or 0. And now after we have learned how to add two integer numbers, we need to learn properties of addition, operation, in Z. Number 1, closure property. For example, if we have 2 plus 3, if we have 2 plus 3, we know that 2 plus 3 equals 5. And we know that 2 belong to the set of integers. And we know that 3 belong to Z and 5 belong to Z. So the sum of any two integer numbers is an integer number. The sum of any two integer numbers is an integer number. So if we have A and B, A and B belong to Z, so A plus B equals C, and C belong to Z. So Z is closed under the addition operation. Number 2, commutative property. Commutative property. So number 2, commutative property. For example, if we have 7 plus negative 5. So 7 plus negative 5 equals 2. And if we have negative 5 plus 7, negative 5 plus 7 equals 2. So the sum of any two integer numbers doesn't change if we commutating their position. If we're commutating their position, the sum of any two integer numbers doesn't change. 7 plus negative 5 equals 2 and negative 5 plus 7 equals 2. So if we have A and B. A and B belong to Z. So A plus B equals B plus A. Number 3, additive identity. Additive identity. So number 3, additive identity. Zero is the additive identity in Z. If we have A belong to Z, so A plus 0 equals A. So if we have any integer number, for example 7 plus 0, 0 plus 7 equals 7. So any integer number plus 0 equals the same integer number, the exactly same integer number. Number 4, additive inverse. So number 4, additive inverse. For each positive integer A, there is an opposite negative integer negative A. And negative A is additive inverse of A. Negative A is the additive inverse of A. So we have additive inverse. So if we need to get additive inverse of A equals negative A. So that A plus negative A equals 0. The additive identity. For example, if we have integer number 7 and we need to get the additive inverse of 7. The additive inverse of 7 equals negative 7. So that 7 plus negative 7 equals 0. The additive identity. And you can verify this sum using the line numbers. Number 5, associative property. Number 5, associative property. If we need to add 3 integer numbers, for example, A and B and C. If we need to add these 3 integer numbers, A plus B plus C. So A plus B plus C equals A plus B all plus C equals A plus B plus C all. For example, if we need to add 7 plus negative 7 plus 5. 7 plus negative 7 plus 5. So we can add any 2 integer numbers first. For example, we can add 7 plus negative 7 and the sum, we will add the sum to 5. So if we take 7 plus negative 7 all n plus 5. So we can add 7 plus negative 7 first. 7 plus negative 7 equals 0 plus 5. 0 plus 5 equals 5. And now in the second part of our lesson, subtracting integers. If we have 7 minus 5, we know that 7 minus 5 equals 2. And if we have 7 plus negative 5, 7 plus negative 5 equals 7 plus negative 5 equals 2. You can verify this sum using the line numbers. So we can subtract using adding. We can subtract using adding. So if we subtract two integer numbers, a and b, define it as a minus b. A minus b equals a plus the additive inverse of p. So if we have a minus b equals a plus the additive inverse of p. So a minus b equals a plus the additive inverse of p. The additive inverse of p. So a plus negative p. And now we need to learn properties of subtraction. Operation in Z. The first property is closure property. If we have 6 minus 2 equals 4. We have 6 belong to Z and 2 belong to Z and 4 belong to Z. So the subtraction of any two integer numbers is an integer number. So Z is closed under the subtraction operation. Number 2, commutative property. The subtraction operation in Z is not commutative. So if we have, for example, 7 minus 3. 7 minus 3 equals 4. But if we have 3 minus 7. 3 minus 7 is equal negative 4. So 7 minus 3 doesn't equal 3 minus 7. So if we have two integer number a and b belong to Z. So a minus b doesn't equal b minus a. Number 3, associative property. The subtraction operation in Z is not associative. For example, if we need to subtract three integer numbers a and b and c. So a minus b minus c doesn't equal a minus b minus c. If we have 7 minus 5 minus 2. So 7 minus 5 minus 2 doesn't equal 7 minus 5 minus 2. So 7 minus 5 equals 4. 4 minus 2 equals 2. 7 minus 5 minus 2 equals 3. 7 minus 3 equals 4. So the subtraction operation in Z. Example number 1. Find the result of letter A, negative 6 plus 6. First of all, we have our line numbers. We start from 0 and move to the left. If our number is negative, we move to the left. We move to the left, the absolute value of negative 6. The absolute value of negative 6. The absolute value of negative 6 is 6. So we move to the left 6 units. So we start from 0 and move to the left 6 units to represent the number negative 6. Okay, we move to the left 6 units. 1, 2, 3, 4, 5, and 6. So we stop here. So now we represent the number negative 6. And we have negative 6 plus 6. So we move to the right the absolute value of 6 because the number is positive. So we move to the right 6 units. And now the answer is 0. So negative 6 plus 6 equal 0. Letter B, 4 plus negative 7. We have now 4, so we start from 0 and move to the right 4 units to represent the number 4. After that, we start now from 4. So, and we have the number negative 7. So we move to the left because the sign is negative. So we move to the left 7 units. Now we move to the left 7 units. We have 1, 2, 3, 4, 5, 6, 7. So, and stop here. So the answer is negative 3. So 4 plus negative 7 equals negative 3. Letter C, 0 plus negative 4. 0 plus negative 4. So now we start from 0 to represent 0 and the number or our number is 0. So now we represent our number 0. And plus negative 4. Plus negative 4. And move to the left 4 units. So we have 1, 2, 3, 4. And now the answer is negative 4. So 0 plus negative 4 equals negative 4. Example number 2. Use the properties of addition operation in Z to find the result of negative 17 plus 19 plus 17. State the property used in each step. So our first step is to get negative 17 besides 17. So we have negative 17 plus 17 plus 19. And now we used commutative property. So our second step is we have negative 17 plus 17. So negative 17 plus 17 all n plus 19. And now in this step we used associative property. After that, the third step, we have negative 17 plus 17 all in. So we will make the operation of addition. So negative 17 plus 17 equals 0 plus 19. So negative 17 plus 17 equals 0. This is
additive inverse.
And now 0 plus 19 equals 19. And now we used
additive identity.
Identity. Example number 4, find the result of each of the following. Letter A, 9 minus 5. 9 minus 5, we need to subtract these two numbers, 9 minus 5, so 9 minus 5 equals, we put the first number, so we have 9, and then adding to the additive inverse of the second number, so we have 9 plus negative 5. And 9 plus negative 5, first we need to represent the set of integers on the line numbers, so we have 0, and to the right we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And we have to the left negative 1, negative 2, negative 3. Then from 0. And we will move to the right because the sign of the first number is positive. So we move to the right the absolute value of 9. So we move to the right 9 units. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we move to stop at the number 9. Then we move from 9 to the left because the sign of the second number is negative. So we move to the left the absolute value of negative 5. So we will move to the left 1, 2, 3, 4, 5. So we'll move 5 units. Now we have number 4. So 9 plus negative 5 equals 4. Letter B. Negative 7 minus 4. Negative 7 minus 4 equals, we put the first number, so we put negative 7. Then adding to the additive inverse of the second number. So negative 7 plus negative 4. Negative 7 plus negative 4, we represent the set of integers on the line numbers. If we have here 0, we have to the right 1, 2, and so on. We have to the left negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11. So we start from 0. Then we move to the left the absolute value of negative 7. So we move to the left 7 units. So we have number negative 7. Then we start from negative 7 and move to the left the absolute value of negative 4. So we move 4 units. 1, 2, 3, 4. So we move to stop at negative 11. Then the sum of these two integer numbers equals negative 11. Letter C. 6 minus 11. 6 minus 11 equals 6 plus negative 11. So we represent the set of integers on the line numbers. We have 0 and we have to the right 1, 2, 3, 4, 5, 6, 7, 8, and so on. We have to the left negative 1, negative 2, negative 3, negative 4, negative 5, and so on. We start from 0 and move to the right the absolute value of 6. So we have 1, 2, 3, 4, 5, 6. So we move to the right and we stop at 6. Then we have the number 6. So we start from 6 and we move to the left the absolute value of negative 11. The absolute value of negative 11 equals 11. So we move to the left 11 units. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we will move and we stop at negative 5. Now we have negative 5. So 6 plus negative 11 equals negative 5.